Thank you so much, Kay and Owen, for being here. So, I usually have a recurrent nightmare when I am very stressed out, and the nightmare is that I am either failing a college level class or I'm failing a master's level class. And that actually comes from real experience. And today, I think I'm gonna have another nightmare because in the early part of this summit, I moderated a conversation about valuing nature and the economics, and I almost failed environmental economics at Chicago when I was studying, and I had to change it to pass-fail. And the other class I almost failed in college was physics. So thank you, Matt. I'm having nightmares tonight. So quantum computing. I have been trying to wrap my head around it, and I'm going to start with you, Kai. When I hear computing, I think about my MacBook Air. How is quantum computing different from what I can do in a regular computer?
Well, the first thing I think that we try and dispel is that in some ways quantum computing is not, for the general audience, computing in the way you would think of it, right? We're not trying to build something that will replace your iPhone, replace your MacBook. Quantum computing is really going to be the new backbone, the new infrastructure of how the internet works, in the same way that you're not buying GPUs to use at home, but you're
buying
using
what?
GPUs. Sorry, you're not using AI on your laptop. You're using it through other means, these large, big infrastructure plays. Quantum is the next frontier of computing. It's what comes after AI to augment AI, to make AI, take AI to the next level, to take math and simulation and science. All of these things can benefit from quantum, and your life will be affected in many ways by quantum computing in the future, but you won't see it. Your banking will be secured by quantum. The next generation of drugs will be simulated by quantum. These are global scale problems, but under the hood. So it's not a consumer product, but consumers across the globe will benefit from it.
Okay, let me see if I got it wrong. So if I got it right, sorry, I probably got it wrong. So quantum is not hardware. It's not like a laptop. It's not like a cell phone. It is the power behind something that will make everything that we do more efficient, probably more sustainable, because if we're being more efficient, we're going to use less energy and all of that. Am I going in the right direction?
You are going in the right direction. And I think Cornelius earlier today, in his talk about biofuels and creating energy from waste, being financially driven is the way to be sustainable, right? Quantum computing is very similar. It has these exponential promises of compute power, but to get there, we have to make money. And quantum computing is more efficient. This is the way. For a system that can fit in a fridge, you could compute something that an entire data center couldn't compute, right? The size of just your home fridge. So, and the energy scales appropriately. But that machine itself is very hard to build, very expensive, and so it needs to compete on all parameters of what compute is. And compute is, now it's not just tokens per second, it's tokens per second per megawatt. Like, the energy that goes into your AI models is really what drives the economics. And quantum computing has a long way to go to beat NVIDIA. No, who's going to beat NVIDIA realistically? But we're going to augment NVIDIA with different solutions, better costs, and new capabilities along the way. And so in some sense it's a green technology, but it's a green technology because it's
efficiency.
It's efficiency.
Owen, what do government officials like me should know about this technology? How do we prepare for, the incoming years of this technology being more out there, the public being more aware of it? I mean, right now governments are going crazy about how to handle AI, and most of our governments don't even know what to do with it. Now you talk about quantum computing, like I said, I'm having nightmares. So what should a government official like me start reading, start focusing on so that we prepare for the upcoming era of quantum computing that you're pushing to get to us faster?
Yeah, it's a good question. And I wouldn't have too many nightmares because even like Einstein couldn't get his head around this, right? So it was very famous that Einstein was like a questioner of like, is quantum technology, this was back in the 1910s, 1920s. So, let's not worry too much about the intricate detail of that. We've got people like Kai and my partner Helmut and these experts to look at, the physics of it. I think where I'm, as a chemist, more interested, I learned a lot about quantum technology because chemicals are inherently based on atoms and molecules, and that means that they're driven by these quantum rules. And we've been trying to simulate these molecules for many years in classical systems, and it's really inefficient. The classical compute does not lend itself to computing these properties of molecules. Sorry, is that okay? There's a right distance to have this microphone.
Apparently.
I'm used to speaking without a microphone, so it's going to be better. So thank you for the feedback. It's much appreciated. So these. But when you think about it, molecules are what drives everything that we're talking about. We talk about carbon dioxide. We talk about all of these, materials and molecules which are impacting our nature and our planet. And we barely understand these from a system level. So I think one of the interesting things for me about quantum is, not necessarily how it works, I trust that to the physicists, but what do we do with it? And how do we use this to address some of the problems we have? The challenge I have with data centers is AI is fantastic for doing certain things. But it's terrible at doing the things that are most impactful, and the problems that it doesn't address the biggest problems that we have and the biggest challenges in society. And I think by having access to these technologies, we should be able to start to think about really delivering new solutions to these big problems, and doing that in a way which is quantifiable and commercially viable. So to the point about how do governments prepare for this, I think, and it's not just about computing. There are other technologies. Quantum is also very useful for making sensing technologies, which allows you to get measurements of your minerals or GPS. We all benefit from this, right? GPS is based on atomic clocks. It's a quantum property, but we can put those atomic clocks now with this new technologies more at the domestic local level. So you can decouple yourself from GPS satellites by having a local atomic clock, and this is going to enable things like 6G, Wi-Fi, internet, and so on and so forth. So there's many different ways that quantum is going to impact society. At all levels, and I think governments need to be aware, and even UK government has recently announced additional funding, EU has announced additional funding, the US government has now has got to go back because of the pace of advancement in the technology and redefine its quantum strategy. So there's a process now where they're looking at this whole space again and refreshing their quantum strategy. So I think every nation, as they need a strategy for nature, as they need a strategy for the people, it's now is the right time to think about it because everybody can benefit from this. And a lot of, like we mentioned in the discussion yesterday, a lot of the challenges that we face are solvable, but we need to link the problems with the solution providers in order to find ways of getting the physicists to think through and to solve some of these problems.
Okay, let's get straight into the problems. We already talked about general concept. It's about efficiency, that will lead to sustainability, less use of resources, more outcomes. It's basically higher power to do things better. That's what I'm understanding. Now, let's talk about analogies. Give us some examples. We have this problem, and that problem has the potential to be resolved or improved using quantum technology.
Okay, so the big example that Novo, one of our LPs, uses is around nitrogen fixation. So this is a huge problem, right? We currently do this using what's called the Haber process. We take nitrogen and hydrogen, we heat it up to 1500 degrees C with an ion catalyst, and we produce a fertilizer, ammonia-based fertilizer. Now, this is a highly inefficient process, right? You have to heat this stuff up to crazy temperatures. But we know that bacteria in the soil do this for free every day, right? So how can we compute enzymes which can produce nitrogen for fertilizer?
Compute enzymes, what does that mean?
So the enzymes are the proteins within the bacteria that do the job of fixing the nitrogen. So they just sit there in the soil, they take nitrogen, they do some clever stuff inside them, and that is a biological catalyst that will turn the nitrogen into fertilizer, and that's how nature survives without having to fertilize it. But with quantum computing, we can now start to think about calculating how do we take this enzyme, this material that the bacteria use, how do we produce synthetic versions of this, which we can commercialize in a factory, and then make this nitrogen, fertilizer, without having to heat these high temperatures. This could be like 5% of global energy saved. And we could then, that energy can go to some other use, for example. And it means that you can distribute distribute the manufacture of these things to more, local places, or you could even just spread the enzyme on the ground, right, without having to do the process of synthesizing the chemical in the first place.
So you reduce emissions, you save money, and you get more impact.
Precisely.
Absolutely.
And that's one tiny example. There's gazillions of these examples. This is one tiny example, which is such a meaningful one.
Okay, you want to share another example?
Oh, well, I was going to say, if that was confusing to you, instead of heating up, nitrogen to 1500 C, you give cow grass and it poops out fertilizer, right? That's the cheeky way of saying nature is perfect. Nature knows how to do these things, and quantum helps us understand a lot of these properties, right? It's kind of insane to think that we can mathematically compute how all of these things work. Well, we can't compute them, but we can write it down on paper, and quantum will allow us to do this type of stuff. That's one of those sort of grand challenges, right? Like, if we could solve 5% of the world's energy use, and sort of, fertilizer was the catalyst for the human population growth and supporting the planet. There's stuff from top to bottom. So there's a company that we're looking at now that has a quantum sort of, it uses math around quantum called tensor networks to do data compression. It's basically a way to pull out very, very small, very, very sparse signals from a very large data set, which, AI can't handle. These things grow very large very quickly. So one of the things that struck home in our conversations with the delegation from Tonga and Tuvalu was undersea cables, right? There's undersea cables running all over the planet that have optical fiber data, that transmit the internet, right, and everything we use. Those things vibrate, and those vibrations can be picked up, but the signal is so small and so noisy that it's impossible to use that data because it's just too big. But with quantum compression techniques, you can actually use existing infrastructure for sensors. Sensors for underwater submarines, for sovereignty and for defense, for fisheries and whales and other sort of ways to know more about your environment, right?
It probably can also be like an early warning system for earthquakes and other.
So that's just one thing, using existing infrastructure that's easy and cheap to implement, as long as we can develop the algorithms and sort of develop these quantum tools, right? So from solving a large part of the world's energy problem to sovereignty for small island nations. Quantum can span all of these gaps. Simulation, we invested in a quantum company that does new simulation techniques. You can design more efficient wind turbines, for instance, right? The shape of the wing can help, right? Or you can measure your resources using quantum sensors and have deep sort of underground models that will let you know exactly what's on your balance sheet in terms of natural resources. So from existing infrastructure to new sort of cheap technologies to global scale problems.
Yeah, so the final example I would give is we just announced today an investment in a very young team from the UK. They're using these quantum compression algorithms to help solve chemistry problems. With their software, they're able to show that they can do 1,000 times faster simulations than you can do with AI on simple molecular problems. And they're using this initially to help drug discovery, but you could also use this for battery materials or storage or catalysts to help convert waste into energy. So these techniques are running 1,000 times faster on the really, frankly, immature technology that we have today. So even on the noisy computers that we have now, they're not very good. It's like going back to the 1950s and using one of these mainframes with all the wires hanging out. Even with those kind of systems, we can get 1,000 times speed up over AI. And if you imagine, what that means 1,000 times less energy per calculation. If you just think it through. So
what I'm hearing is that what quantum is going to help us do is increase our analysis or reasoning capacity to be able to tackle problems in a faster, more efficient way.
Effectively, we're blind to anything that is below a certain size, right? Our current computational techniques, current ways of approaching these things, we have a blind spot. And that blind spot is is where some of the biggest challenges we face as a society are. And so basically, it's like opening a whole new window on a world that we can't really see and calculate properly. And that provides opportunities that solve some of the biggest challenges that we face as a society.
So our time is running out. Closing words?
Well, I was going to take it back to your original question of you as a governmental representative. What should you be thinking about? You know, something Owen said reminded me that the only thing in the U.S. that has had bipartisan support over the last few administrations was quantum, right? Trump 1, Biden, and Trump 2, quantum, right? It is a national priority that everybody can get behind. And so, to me, that says that, you know, it's important enough for every country to have a strategy, and we believe that the time, it's appropriate, right, that one of the biggest missing pieces to quantum are users, are problems, right? And your country, you know what your problems are. You have the opportunity to come up with a strategy, engage with the experts, people like us, the companies we invest in, and generate value for your society, right? Because you can, if you are the tip of the spear on the most advanced solutions that could potentially be applicable globally, right? You can capture that IP, generate that IP, and create that value for your society.
Okay, so you lead the largest fund fully focused on investing on quantum technology. How can companies and governments engage with you? What's the step? Do we just go up to you and set up a meeting? But how do people usually engage with you?
We won't bite, I promise.
Yeah, I mean, we're really happy to have conversations. I mean, you know, there's many different ways we can engage. I think for us, it's about raising awareness. It's about making sure that we're addressing, you know, some of these challenges. For us, you know, it's a passion to develop the technology, but also then to apply it in a way which has the biggest impact. And there are very, very few technologies in the current kind of ecosystem that could have this global level of impact. You know, and from a childhood up, I've been, you know, passionate about the environment and passionate about sustainability, and invested in many companies that, you know, have options to look at this. But now we have this real paradigm shift, and I think it's really about the time to engage. We have such a big network as well. If we can't help, we can also find people that can. And I think, you know, just don't worry about the technology so much. Think about, you know, what are the biggest unsolved challenges, and let's, you know, make those challenges available so that the scientists working on these technologies can figure out how can we find solutions to them. I think that's the way that I would frame the conversation.
I mean, I love it because one of the biggest challenges, at least on the climate space, is, for example, how do we make climate adaptation bankable? You know, something that for the longest time has been charity-based because no one has been able to figure out how do you make money out of providing assistance for, you know, disaster relief and all of that. So I'm going to be following up with an email to see how we can chat along these lines. Thank you so much, Kay and Owen.
Thank you, Owen.
I guess I'm going to sleep better tonight, and thank you, everybody. I hope that you grasp some. I've been talking to Kai since 2 days ago, just like trying to pull information out of him. I feel a little bit better now. Thank you.
Thank you.
Thank you.